once again, dear students. Today we are going to continue with our lesson for the fourth quarter, which is on the measures of variability, grouped and ungrouped data. First, let us define the measure or measure of variability. The measure of variability refers to the spread of the values about the mean. These measures help visualize the shape of the dataset together with the extreme values. Smaller dispersion of scores arising from the comparison often indicates more consistency and more reliability. On the other hand, if it has a greater dispersion, then it means that the data is less consistent or less reliable. The most commonly used measure of central of variability are the range, the average deviation, the standard deviation, and the variance. So those are four of the topics or subtopics that we are going to discuss today as we solve examples. Let us start with solving the range. Before we start, let's have a quick game. Can you find the difference between the highest and lowest number in the given set of numbers that I am going to show you? So solve as quickly as you can. For letter A, what is the difference between the highest and the lowest number? Okay, the highest number here is 95. Am I right? And the lowest number is 78. When we subtract those two, 95 minus 78 is equal to 17. Okay, so the answer to letter A is 17. Next, B. Can you solve for the difference of the highest and the lowest number? All right, our highest number is 23, or no, it is 25, and the lowest number is 14. Subtracting those two, the result is 11. Next, letter C. 23, 45, 60, 20, 25, 44, and 38. The highest number is 60, and the lowest number is 20. So subtracting those two, 60 minus 20 is equal to 40. All right. Next, we have this set of numbers. What is the difference between the highest and lowest? The answer is 8. Am I right? Because the highest number is 9 and the lowest number is 1. And 9 minus 1 is equal to 8. That is the answer to letter D. And for the last one, what is the difference? Our highest number is 165 and the lowest number is 113. Subtracting those two, the result is 52. From this activity, we have already done the first measure of variability. Okay, we have already solved for the measure of variability for each of the set of the data. And what is that? I'm referring to range. Okay. Again, range. What we have solved is actually the range of the set of data. It says there, the range is the simplest measure of variability. It is the difference between the largest value and the lowest value. It is the measure which requires the simplest computation. So simply subtract, identify the highest and the lowest, and then subtract them. And that is the range. So here is our formula. The range is equal to the largest value minus the smallest value. We have here an example. For example 1, the grades in mathematics of 10 students of 2 sections in ECN VHS were as follows. Here are the grades for section Einstein and the grades for section Archimedes. And how do we get the range for Einstein or section Einstein? We subtract the highest, which is 95, and then the lowest, which is 88. The result is 7. For section Archimedes, the highest is a 95. Oh no, it is 98, and the lowest is 87. Subtracting those two, 98 minus 87 is equal to 11. From that, what can we infer? Well, here is the clearer solution, but we have the same answer. Again, the range for section Einstein is 7, and the range of the grades of section Archimedes is 11. We can then say that the scores of the Archimedes section has greater variation or more dispersed than that of the score of Einstein, since the range is greater than that of the other one. Okay, here is another example. The following are the daily cases of COVID-19 in 2 successive weeks. For week 1, here is the set of data. Week 2, here is the set of data. We have to compare the range between those 2 weeks. For week 1, the highest number of cases is 210 and the lowest is 98. We subtract those two, so 210 minus 98 is equal to 112. That is the range for week 1. How about for week 2? The highest number of cases is 264 and the lowest is 122. When we subtract those two, the result is 142. From that, we can identify which week has a greater dispersion. Okay, and for our analysis, since week 2 has a greater range, so we can say, or this indicates that the number of cases of COVID-19 on week 2 is more dispersed or scattered compared to that of week 1 because it has a greater value of range. And we have here more examples, but the answer is already given. Okay, for number 1, 25 is the highest number or largest number and 1 is the lowest number. And 25 minus 1 is equal to 24. For number 2, the largest number is 92 and the lowest number is 75. Subtracting those two, 92 minus 75 is equal to 17. Number 3, the largest decimal is 2.5 and the lowest is 1.0. Subtracting those two, the difference is 1.5, so that is the range of the data in number 3. If that is for ungrouped data, here is how we solve for the measure or the range of group data. Our formula is simply this. Range is equal to the highest class boundary minus the lowest class boundary. Okay. So in this case, we have here an example. Our upper limit, the upper limit of the highest interval is 50 and the lower limit of our the lower limit of our lowest interval is 16. How do we get the exact boundaries? Okay, for upper limit, we get its average and the lower limit of the next one, but there's none. That's why we simply write there 50.5. Okay, so the exact boundary of this is 50.5. On the other hand, the exact lower boundary is 15.5. Alright, so we have those values and we substitute it to our formula. Our formula is this: the highest class boundary plus the lowest class boundary. Our highest class boundary was 50.5 and then the lowest is 15.5. So when we subtract those two, the result is 35, and that is the range of this group data. Isn't it easy? Yes, it's very easy. Now, for average or mean deviation, this is our second measure of variability. First, let us deal with ungrouped data, or the mean deviation of an ungrouped data. So we have here a procedure. For step 1, we first find the mean of all the cases, and then step 2, find the absolute difference between each score and the mean. And then step 3, we find the sum of the differences and divide it by the number of scores or cases. Let's go over those steps as we answer some examples. By the way, here is our formula. So MD, remember we are using capital D, M, and then capital D, because if we are using MD, wherein we have a lower case D, that is for median. Okay, but for M and then capital D, capital M, and capital D, that is for mean deviation. Again, this is for median. Okay, the formula is MD is equal to the sum of the absolute value of the values of X minus the mean. And then divide that by the value of N, or the total number of cases. Okay, let's have an example. Find average or mean deviation on the following heights of students in centimeters. First, let us solve for the mean. How do we do that? Since it is an ungrouped data, we add all of the values and then divide it by the total number of cases. So 125 plus 122 plus 115 plus 127 plus 120 plus 117 divided by 6. Divide those two. The total of the numerator is 726 divided by 6. The result is 121. That is only the mean, that is not yet the mean deviation. We use that to accomplish step 2. For step 2, we find the absolute difference between each score and the mean. Since we know that the mean is 122, am I right? Oh no, it is 121. It's already stated here. Okay, we simply subtract those and then get its absolute value. For the first pair, 125 minus 121 is 4. 122 minus 121 is 1. 115 minus 121 is negative 6, but we will get its absolute value. That's why what is written there is positive 6. 127 minus 121 is 6. 120 minus 121 is supposed to be negative 1, but we will get the absolute value. That's why we have there positive 1. 117 minus 121 is negative 4. Its absolute value is positive 4. And then the next thing that we will do is to add all of the values of the difference between the value of x and the mean. Okay, 4 plus 1 plus 6 plus 6 plus 1 plus 4 is equal to 22. That is for step 2. Next, for step 3, we find the sum of the difference and divide it by the number of scores or cases. We simply substitute the values that we have obtained in step 1 and 2 to our formula. Okay, so the sum of the difference between the values of x and the mean is 22, right? And the value of n is 6. We divide those two. 22 divided by 6 is equal to 3.67. That is the mean deviation. That is the mean deviation for this example. Okay, this time we discuss how to solve for the mean deviation of a grouped data. Here is the procedure. For step 1, we determine the class mark. Again, we use the symbol capital X for it, and find the product of the frequency and the class mark under column Fx. So it's like solving for what was that? Mean, right, of group data. Afterwards, get the summation of F times X. Okay. Then step 2, solve for the mean using the data obtained in step 1. Step 3, find the absolute difference between the class mark of each interval and the mean. For step 4, we multiply the frequency by the answer that we've got in step 3 for the column F times class mark minus mean. And then afterwards, get the summation of F times X minus the mean. Okay, and step 5, solve for the average or mean deviation by using the formula. Okay, so here is our formula in solving for the mean deviation of group data. We have there mean deviation is equal to the sum of all frequencies times the absolute value of the difference between the class mark and the mean. Divide that by n, and that is the mean deviation. Let's have this example. Find the average or mean deviation of the results of the survey made by students regarding the number of sleep-in hours in a day of the grade 7 students of Easy and VHS. Okay, so here is our data. Follow our steps. Alright, so we have here our expanded table. We have here the given value of x, and then its frequencies. Okay, so our intervals are this: 13 to 15, 10 to 12, 7 to 9, 4 to 6, and then here are the frequencies. From those frequencies, we can add them all to get the value of n. 5 plus 25 is 30, plus 8 plus 2, that is equal to 40. So the value of our n is 40. Next, we solve for the value of x, or the class mark. Again, we do that by getting the midpoint of the lower limit and the upper limit. Okay, so 13 plus 15 is equal to 28, divided by 2 is equal to 14, or simply determine the number between 13 and 15, and that is 14. Between 10 and 12 is 11. That's why the class mark for this interval is 11. For 7 and 9, the class mark is 8. And then 4 to 6, the class mark is 5. After that, we complete our next column, the product of F times the class mark. So 5 times 14 is 70. 25 times 11 is 275. 8 times 8 is 64. 2 times 5 is 10. And then we get the total of the product of the frequency and the class marks. The result is 419. After that, we solve for the mean. Our mean is obtained by dividing this 2. 419 divided by 40. When we divide those two, the result is 10.475, or 10 and 475 thousandths. Okay, given the value of mean, we get the value of class mark minus the mean, and then it has an absolute value. That's why we get the positive equivalent of those differences. Okay, starting from this pair, so we have 14 minus 10.475, which is our mean. So the result is 3.525. Next, 11 minus 10.475 is 0.525. Next, 8 minus 10.475 is 2.475. And then lastly, 5 minus 10.475 is equal to negative 5.475, but again, we will get the positive equivalent, or the absolute value. That's why we will write 5.475. Next, we multiply our frequency by the absolute value of the difference between the class mark and the value of the mean. Okay. Or we simply multiply these two pairs. 5 times 3.525 is 17.625. 25 times 0.525 is equal to 13.125. 8 times 2.475 is 19.8. And 8, or what's that? 2 times 5.475 is equal to 10.95. We add all of those to obtain this, and the sum is 61.5. By completing this table, we can obtain the necessary information, which we will substitute to our formula. Here is a clearer view of the solution that we have done a while ago. Okay, this is a cleaner one, but we obtain the same results. The value of n is 40. The product of the sum of the product of the frequency and the class mark is 419, and then this is, or the sum of the product of the frequency and the difference between the class mark and the mean is 61.5. We can substitute all of this to our formula. Our formula is this, and we have already obtained this value, or the value of this, and it is 61.5. So our numerator is 61.5, and then the value of n is 40. When we divide those two, the quotient is 1.538, or 1 and 538 thousandths. That is, we are down to our third and fourth measure of variance or variability, which is the standard deviation and the variance. Let us first deal with examples in solving for the standard deviation and variance of an ungrouped data. Here, there are steps that we also need to follow. For step 1, we find the mean. Step 2, subtract the mean from each cases, x minus the mean, then get the square of their difference. Step 3, get the summation of the squared difference. And then step 4, solve for the standard deviation and variance. And we have here our formula. ST, or standard deviation, is equal to the square root, square root of the sum of the difference between x and the mean, the quantity squared, over n. For us to get the variance, we simply square the value of the standard deviation, so that they are actually interrelated. Let's have an example. In a survey made by DOH on the pandemic COVID-19, the following are the daily number of cases of the infectious virus. Find the standard deviation and the variance of the data gathered. For step 1, we again find the mean. We do that by adding all of the scores. So scores, or the total number of cases per day, 212 plus 185 plus 230 plus 310 plus 288 is equal to 1,225. Divide that by 5, the result is 245. So that is just the mean. We need the mean to accomplish the next steps. Okay, step 2 and step 3 are already here. For step 2, we are going to subtract the value of x and the value of the mean. We have solved the mean a while ago, and the value was, what was the value of the mean once again? It is 245. Okay, that's why for the first one, 212 minus 245 is equal to negative 33. Next, 185 minus 245 is equal to negative 60. 230 minus 245 is negative 15. 310 minus 65 is 65. 310 minus 245 is equal to 65. 288 minus 245 is equal to 43. Then we square those results. Negative 33, the quantity squared, is positive 1089. Negative 60, the quantity squared, is positive 3600. Negative 15, the quantity squared, is 225. 65 squared is 4225. And 43 squared is equal to 1849. We get the sum of all of those, and the result is 10,988. We have already obtained the necessary data. We simply substitute it to our formula. It is already substituted in our given. So we have a standard deviation is equal to the absolute value of the sum of the square of the difference of the values of x and the mean, which is 10,988, divided by 5, or the value of n. We simplify first the number inside the radical sign. 10,988 is equal to 2197.6. And when we get the square root of that, the result is 46.879, or 46 and 879 thousandths. Okay, so for the variance, we simply square this value. So 46.879 times 2 is 2,197. Or if you will go back before getting the square root, you can already say that the value inside that radical sign is the variance. Okay, variance. Okay, I will no longer write it. That is the variance. Okay, next. So steps in solving for the standard deviation and variance of group data. So this time we are going to solve for an example that involves a group data. We also have a series of steps. So first step is for us to make a table. Find the class mark or midpoint of each class mark, then get a square of the class mark. For step 2, we multiply the frequency by the square of the class mark or midpoint for each class. And then for step 3, we multiply the frequency by the class mark or midpoint for each class. And then step 4, find the summation of the product of the frequency and the square of the class mark. So the sum of the product of the frequency and the square of the class mark. Here is the symbol. Okay, and here is the symbol for the other one. And of course, for the fifth one, we solve for the standard deviation using this formula. Standard deviation is equal to the square root of n times the sum of the product of f and x squared minus the sum of the product of f times x, the quantity squared, over n. When we square that, the result is the variance. Okay, here is the example. We find the standard deviation and variance of the following data. How do we do that? We follow the steps. So in following the steps, we will obtain all of these values. Okay, so when you answer the activities, simply construct a table. X for the class mark, and then x squared for the square of the class mark, f times x squared, and then f times the value of the class mark. Okay, first, for us to get again the class mark, we simply add our lower limit and upper limit for each interval. Or you may count. So we have 16, 17, 18, 19, 20. The number in the middle is 18. So the class mark for this interval is 18. Next, for the interval 11 to 15, we get the class mark, which is 13. For the next one, it is 8. And then the next one is 3. We square each of those to get to complete the fourth column. So 18 squared is equal to 324, 13 squared is equal to 169, 8 squared is equal to 64, 3 squared is equal to 9. Then we multiply those two, the frequency and the value of x squared. So 2 times 324 is equal to, 8 times 324 is equal to 2,592. 5 times 169 is 845. 15 times 64 is 960. And 2 times 9 is equal to 18. Okay. And lastly, for the last column, we simply multiply our frequency and the class mark. So 8 times 18 is 144. 5 times 13 is 65. 15 times 8 is 120, and 2 times 3 is 6. Add all of those to get 335. So we have the value of the sum of the product of f times the class mark, and then the sum of the product of the frequency and x squared. Okay, here is again a clearer answer, okay, or solution to our example. But again, we have obtained the same result. We substitute the values that we have obtained in our formula. So the value of n is again 30. The value of the sum of f times x squared is 4,415. And then the sum of f times x is 335. We square that. And then we divide the result by 30. Simplifying further, 132,450 minus 112,225 is equal to 20,225. And then we divide it by 30. When we divide those two, we will obtain 674.167. And we can already write that as the variance. But when we get the square root, the result is 25.965. That is our standard deviation. So again, when we square that result, we get the value of the variance. So here are the values that we have obtained: 25.965 for the standard deviation, and for the variance, the result is 674.167. That is it for our lesson for today. Thank you so much for listening. Goodbye.